Okay, so the condition we have is completely dead at the UI. So we gotta troubleshoot, figure out why we've got nothing at the UI panel. All right, step one, I'm gonna confirm power. So circuit 19 is here. It is on. Just to be sure it's on, we'll flick it. Okay, I've taken the liberty of taking a few things apart down here under the kick plate. So here's our 120 volt coming into the dishwasher, and if you follow that, it's this fitting that's feeding up into this is where the master control board is up in here. So first thing we're going to do is we're going to take this apart at this fitting, and we're going to check that for voltage. Okay, here we are with that test. So we've got leads from our multimeter plugged into the black and the white wire on this terminal connector, and we have 120. So we've confirmed power is entering the unit and reaching the master control board. So that is step one. Okay, so here's that fitting that we just plugged back in. This is where we just tested to confirm the 120. And I just want to show you guys what this powers. So it powers up this, which is the main controller for the dishwasher. And we're going to talk later about that fast blinking light. I got some frustrations around that, but we'll discuss that at the end of this series. So 120 enters this control board, and it leaves this control board on this harness right here at a lower voltage, and that's what heads up to the UI panel and the door. So that this smaller wiring harness is going to travel up into the door to power that UI panel, the panel we looked at the beginning, which is dead. So what we're going to do right now is we're going to check for proper voltage on these pins, which should be stepped down from the 120 down to about 13, 14 volts. We're going to go see if we have that power. Okay, here's the text and the diagram in the shop manual for the dishwasher that shows us where we should find that 13.5 volts DC on pins 2 and 5 leading from the main control onto the wiring harness that's going to go up to the UI. So that's where we're going to test pins 2 and 5, looking for the 13.5 volts DC. Okay, here we are with the control panel turned so that we could access these pins, and we needed to read between pin 2 right here and so 1, 2, 3, 4, 5. So between pin 2 and pin 5 is where we needed to read for voltage, and I can't do that with the camera shot to show you guys the result of that reading. Just don't have enough hands for the situation, but we did get that reading, and we did get it successfully. We have 13.5 volts presenting right here on pins 2 and 5. So the issue, we've ruled out the incoming power here is 120. We've ruled out the control board itself because the control board is presenting the proper voltage at the terminal connector here. So now we're down to the wiring harness, which heads up the door, or the UI itself. So we've taken this out of the equation, we know that our problem is somewhere upstream between this connector here, and the UI itself. So on to the next troubleshooting steps. Okay, ordinarily, our next troubleshooting step would be plugging this back in to the connector that we were just looking at and going to the other end to test for voltage. That would be the normal next troubleshooting step. But in this case, that would require taking the dishwasher door apart. So before I take the door apart, instead, I'm just going to physically inspect this cable harness, the parts that are visible, for any damage before I take the door apart to do any further testing. I just want to rule out any damage I can find quickly down here in this harness. See if I can save some time. With 13.5 volts found at the main control, the next logical troubleshooting step is to look for the 13.5 volts up at the UI. This is the step that we're skipping for the moment because of the difficulty in taking the door apart. And we're just jumping ahead to checking the harness for physical damage, which would normally be a later step, but we're going to get to it instead of taking the door apart. Okay, that hunch paid off. We did save some time. So what we knew is that the blue yellow wire and the black green wire are the feeds for the 13.5 volts up here to the UI. So what we did is we played around a little bit with those wires at the connector, and we did find that they weren't seated very well in that connector. So ultimately, this connector needs to be remade, re-terminated, or a new harness thrown in here completely would be the permanent fix. But just fiddling around a bit and pushing those wires back into place, we have power. We've got a responsive UI. So this is a temporary fix. Dishwashers vibrate as they work. As this dishwasher vibrates, undoubtedly, the wires that I just pushed back into place are going to work themselves loose again. We'll see this failure again until we permanently remake that fitting or replace the harness entirely. I'm going to look at the cost of the harness and consider just replacing it because I'd have to buy the connector to remake the connector anyway. That's not anything I can do tonight. We'll ride with this temporary fix tonight, button everything down as tight as we can, and hope we get a lot of loads in before this thing vibrates loose. Now let's talk about my frustration on that rapid green blinking light on the main control board. So this is the section from the shop manual for the dishwasher about how to use that light to troubleshoot. And we see that we're supposed to look at the service LED and follow the accompanying table to determine what error that LED is indicating based on its blink pattern. So we had a completely rapid blinking pattern, almost a continuous blink nonstop. When we check the table, that flashing rapidly 4 times a second, that's supposed to mean that we have to replace the main control board entirely. Guess what I did? I bought one. Guess what I didn't need? A main control board. So my lesson on a GE washer is I will not trust that blinking service light in the future. I'll do a lot more troubleshooting before I just run out and buy a part based on that service LED. The book says the service LED is supposed to be a reliable indicator. It is not reliable in my experience.